So first of all, give yourselves about a minute to try and solve this question using these answer choices. Then come back. So this question is taken from Data Sufficiency Miscellaneous. It's one of the lessons that is being taught during the course and specifically during week 2. And these are basically the answer choice. These are slightly confusing. Most people taking the examination do know of the method I'm going to show you in a second. Not everybody taking this examination actually knows how to do in a very adept manner. So we'll talk about that a bit later on. But this is what the method looks like. It's this. And again, during the course, we're going to talk about it slightly more at length, but these questions are data sufficiency questions. Data sufficiency questions show up only on the GMAT. These questions are relatively tricky questions. All data sufficiency questions are must questions. What that means is that when you say, for example, that the correct answer choice is B, that means that statement 2 alone is always must be sufficient, but statement 1 alone does not have to be sufficient in and of its own. So how would you go about trying to solve this question? The question is, assuming that P and Q are prime numbers and P is less than or equal to Q, is P plus Q a composite number? So first of all, there is a vocabulary question here. Do you know what a composite number is? And again, not everybody taking the examination knows. What I do want you to know, as always with the takeaways, and I mentioned that you will always, underneath every question during the course, you will see what specifically solved that particular question. You will see the takeaway in this case. If you see the words factors, if you see the words prime or composite basically is just fancy wording for non-prime, then the question type is integers, factors, divisibility, and prime numbers. And of these are the 3 pieces of information that we need to know. So first of all, I'm asking my students always, please know these primes by heart, 2, 3, 5. Now, you would notice that 2 is a prime number. In fact, 2 is the first prime number and the only even prime number. Vaguely, some of us remember that a prime number is divisible only by itself on 1. That is actually an inaccurate, insufficient definition of what a prime number is. And again, I can't go into in depth right now. All prime numbers, that means if 2 is the first prime number and it is the only even prime number, that means that all prime numbers other than 2 are going to be odd. So again, going into the question, is P plus Q a composite number? I have no idea what I need specifically to do here. If going back to this MO of how to deal with all of the data sufficiency questions, I need to simplify it. So simplification would be P plus Q. Is that equal to a composite? That's going to be my simplification, but not much more than that. I do not know what I need in order to solve this particular question. Statement number 1 tells me that P is not 2. If P is not 2, that means that P will have to be 3 or 5 or something of that sort, and Q will also have to be 5 or 7, something of that sort. But if 2 is the first prime number and the only even prime number, and P is not 2, that means that P is going to be odd. If P is odd and Q is either greater than or equal to P, that means that Q is going to be odd as well. What happens when you add an odd number to an odd number? The answer is you always get an even result. So what I know right now is that P plus Q is equal to an even number, and that even number is greater than a 2. Since all of the prime numbers are odd numbers, assuming that they're greater than a 2, then I know that this P plus Q sum is going to be even. In other words, it is going to be a composite number. It is going to be divisible by 2. The first statement is sufficient by itself. If you're uncertain, what you can do is 3 plus 5, you get an 8, and an 8 is a composite number. It's not a prime. If you plug in P equals a 3 and Q equals an 11, you're still going to get 14, and 14 is still a composite number. So it always gives you an answer to this. P plus Q is a composite. The first statement is sufficient by itself. Going to the MO, if the first statement is sufficient by itself, boom, you know that the correct answer choice is going to be either A or D. So even if I were to have to gamble at this point, I would have gambled A or D, and I would not have gambled B, C, or E. Statement number 2 simply tells me that P is not equal to Q. But if P is not equal to Q, P can be a 2 and Q can be a 3. In that case, P plus Q is going to be 5. Is 5 a composite? The answer is no. Or P is not equal to Q. P can also be 3 and Q can be 5. In that case, the sum is going to be an 8. So is 8 a composite? The answer is yes. So since statement number 2 by itself gave me 2 contradicting conclusions, and again, this is something that we're going to work on rigorously during the course, and statement number 2 was indeterminate. It was kind of hesitant. It tells you, oh, wait a minute, it's not a composite. Sometimes it is a composite. I know that statement number 2 by itself is insufficient. If the first one was sufficient, statement 2 was insufficient. The correct answer choice is A. Instead of memorizing these, you actually need, if you do know what you're doing during a GMAT course, you do need to know these.